Hey guys, this is Miss Sumler. I wanted to talk to you all about math night. We're having a trunk or treat, and I hope you all can make it because you're going to be walking away with this really awesome bag. This has so many great activities in it. I'm just going to take out a few of the things and show you what's in there and walk you through a little bit. So there are number cards in here and fraction cards. There's dice, a spinner, and then even game board pieces. There is a game board in here, spin it to win it. And there are directions in this activity book. They have it in English and also in Spanish. So the directions to all the games are in here and all the pieces that you need are in here too. So every single thing you need is in this bag, and you can only get this bag if you are coming to our trunk or treat, which is Tuesday. And I believe it's 5:30 to 7:30. So hopefully you got that orange paper that went home and you decided to come and you sent it back. So here's some of the things that are in the bag. There are some number lines that can be, there's dry erase markers that are given to you so you can write on them with dry erase. There is some fraction stuff in here, and I'm going to talk a little bit about the fraction tiles because they're awesome. There is game boards for Win the Grid, Squared Away, all these different games, 500 Club, whole numbers as fractions, row of four. All of these games are explained in this family engagement activity book. So when you open it up, you would just have to go to whichever game you want to play, read the directions, and go ahead and play it. So this is what I'm going to do. I am going to share just one of these games, how I would play it and why I think it's valuable. And then I'm going to show you some strategies for our third grade classroom that you're going to see your kids doing for math. So I'm going to share my screen real quick, and you should be able to see the board that I'm sharing. Fingers crossed you can see this. So right here, I gotta slide it over. Right, if it will slide. Okay, not sure why I can't get it to come on over. Hold on. Alrighty, let's try it. Hopefully that can be seen. Maybe this is why. Nope, it still doesn't want to slide over. Right, let me stop my share and share that again. Working with technology, tricky, tricky, tricky. Okay, I think you can see this. So fingers crossed you can see what I'm showing you. So these are all in the bag. And you can see that we've got one hole, and then we've got parts of the hole so kids can actually physically see half and a half make the hole, and they can layer it over top. From there, 1/3, another third, another third, so 3/3 make the whole. So they can build and see that, and when we lay them out like this, you can see the relationship between them. You would want your child to make connections with these, saying, oh, well, I noticed that 2/4 is the same size as a half, so they're equivalent fractions. 2/4 is the same as 1/2 in this situation, or it takes 4/4 to make a whole. But if I remove one of those fourths, maybe they can start to see, oh, 1/4 and 2/8, they're the same size. So 3/4 is equal to 6/8. So things like that, being able to add and subtract and find equivalent fractions. And then also maybe see how many eighths would make up the half, and hopefully they could see it, but they might have to layer it right on top to be able to see that. So things like that, we really want to build those connections, and using these little pieces can certainly help. And there are some games within this book, this one here, that involve using those tiles. So that's just something I wanted to share. This is a really good resource to have. This game, Rounding Rodeo. So the directions are here in the book on page 8 and 9, but I'm just gonna kind of show you how to play it a little bit. So I'm gonna set that aside, and the game board for Rounding Rodeo. Lost my game board. Had it right there. I think I put it away. Yep. Sorry, I put it back in the bag. So we've got 2 of the same exact cards here. So if you're playing with your buddy would have one and you would have one. And then there are dry erase that have been given. So these really awesome dice, love them, have 0 through 9 on them. So you won't be skipping any digits. But I'm going to roll, and I have a 6, an 8, and an 8. So I could make this 688. I can make it 868. I have some choices here. So let's say I go with 868. I have to think, is that closer to 800 or closer to 900? For me, I'm going to say it's closer to 900. So I'm going to lasso, rodeo, my 900. And then my buddy would roll. And I've got a 1, or they've got a 1, a 3, and a 0. So they could say this is 13, 0, 1, and 3, and they could say that's closer to 10. They could change that and say, that's 130. 130 is closer to 100, and they would lasso that. They could say 301. It's kind of up to them how they want to do that. So if it's 301, then they're closer to 300. So any way you swing it, however they're looking at these numbers, they're going to lasso on their game board. So if they went with 301 or even 310, they would lasso 300. And you just keep playing back and forth. And one of the reasons why this is such an important game is because when students are rounding, they're essentially estimating, and that helps a great deal when we are adding, subtracting, multiplying, dividing. To be able to estimate is really huge. So the first player that lassos all the numbers on their particular game mat wins. So that's why some strategies involved here. If I had already lassoed 300, I wouldn't want to do 301 or 310. I would want to do 31 if I need to lasso 30, or even do 13 if I'm still trying to lasso 10, because I'm trying to get everything lassoed on my game board first. So this is a great game to play. It's also something they could potentially play by themselves if nobody is there playing with them, as long as you teach them how. And if they have some time on their own and you're not able to play with them, you can tell them, hey, play Rounding Rodeo, but play it by yourself because I'm not there with you right now. And you can just keep rolling until your game board is full. So really fun game, just one of many, many games in this activity book. Matter of fact, I think there's almost 20 games in here. So definitely recommend using these, playing as often as you can, but once a week at least. I would venture to say, if you're playing once a week, then you could do that for the rest of the school year, and it's just a fun way of incorporating math. So again, this awesome bag you're going to get if you come to our math night trunk or treat tomorrow, which is Tuesday. The other thing I wanted to show you, I'm going to slide all this away, is some stuff we're doing in the classroom. So third grade is huge on multiplication, division, fractions. We're doing a lot of stuff, but multiplication is probably what you're going to see first. So I'm going to give an example here. Students might, and this is not going to be the first thing they do. We're already doing multiplication, but if we do 23 groups of 6, hopefully they know that we do not want to make 23 groups of these little 6 ones, because that's going to take forever. At that point, once we're up to numbers 2-digit by 1-digit, they already kind of know this, the commutative property, that you can switch it into saying, well, there's 6 groups of 23, because that's the same thing. Very different pictures, 6 groups of 23 versus 23 groups of 6, because 23 groups of 6 would be 23 circles of these 6, and that's a lot to do. So instead of that, we're going to turn it into 6 groups of 23. So you'll see them doing things like this, where they've got the models, 2 10s, 3 1s, and you don't have the models at home. However, you're going to see them drawing when they're solving math problems. You're going to see them drawing, and I'm going to show you what that would look like. So if they had 23 and they had it 6 times, this is what they'd be building in the classroom. You'd see them actually building here. Let me make sure you can see this. There we go, a little bit better. So 23 is shown here 6 times. So they understand the equivalence here. However, if they're drawing it, what you're going to see them drawing doesn't necessarily look like this. You're going to see them drawing a picture of 2 10s, 3 1s, and probably circling it and doing that 6 times. So that's kind of the first step to being able to understand what we're seeing here with 23 groups of 6 groups of 23. This leads into a more efficient way of solving. So what I'm actually going to do is just restructure these 1s and 10s, and I'm going to kind of put them together. So we're going to put all of our 10s together, and we're going to put all of our 1s together. So we have an array, which is a rectangular shape that has rows and columns to it. And it makes much more sense to them drawing it on paper than to draw 2 10s, 3 1s, or 23 rather, to draw that 6 times and have to count that all out. So this is something that you would see kiddos doing too. So if you look, one of my rows is 23. So I've got 10, 20, 21, 22, 23. So I actually have 6 groups of 23, just like I did before. Nothing changed except the way I structured it. So I just essentially moved it to be a little more linear. But this builds into the area model. And in doing the area model, what kiddos would do is represent this array. And I'm going to draw it awfully large. This is not what they would do. They would start out doing this, but then eventually it'd be much smaller on paper. So we've got this big rectangle. And here's my rows. I have 6, boom, 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 rows going across, and each row has exactly 23 in it. So this is a 6 by 23 rectangular array. Then they start to look at it like, okay, I can break this up. So I have my 10s over here. I can break up 23 and look at it like, oh, well, this is 20 and this is 3. So now I'm looking at it a little bit differently here. I'm going to just draw a line here to kind of show that these are the 20 and this is the 3. And it's still, this is not 20 in here. This 20 or 20 plus 3 is the 23 broken up. But what we're actually doing is saying, okay, well, this is 6 groups of 20. And over here, we still have 6 groups, but it's 6 groups of 3. So 6 groups of 3. So this gets into the distributive property here, where they're now able to see this in parts, and they're going to be adding that together. So I'm going to just move the models out of the way, slide them on down here. But I want you to remember what was there, because now when they're writing and recording, they're going to draw something like this, draw this area model, and they're going to say, all right, 6 groups of 20, which is what was in here. That's the same thing as 120, because I can count by 5s. I can go 20, 40, 6. I'm sorry, I'm not count by 5s, but I can think about 100, like $100 is 5 20s. Some kids know that, some kids don't. Depends on their money experience. Or they can think 20, 40, 60, 80, 100. That's 5. 20 more makes the 120. So if they can do this, 6 groups of 20 is 120. They can totally do this, 6 groups of 3 or 3 groups of 6. Either way, that gives them 18. So now all they're doing essentially is taking the 120 and the 18 and putting them together, which is down here at the bottom. So here at the bottom, 6 groups of 20 again, 120, 6 groups of 3, 18. When we put it together, we get our total of 138. So when they walk away from this, they should know that 23 groups of 6, 6 groups of 23, however you want to read it, is equal to 138. I know this is not how we were taught at all, not even close, I know we were taught to just stack it. Let me show the little stacking. You're 23 times 6. I know we were taught this. 6 times 3 is 18. You carry the 1. Nobody knows why. You just do it. 6 times 2, I know, is 12. You know, that's what we were taught. 1 more makes 13. But this is really 3 groups of 6 or 6 groups of 3 that you're seeing right here. And this is not really 2 groups of 6 or 6 groups of 2. It's 6 groups of 20 that you're seeing right here. So we want them to have that understanding that this is 6 groups of 20. And yeah, we want them to get that that's 120 and it's 18 being put together, which equals that final 138. And I know as a parent, you're probably thinking, that's a whole lot to write down when they could just do this itty bit right here. They are going to get to that itty bit right there. And if they are aware of that and they understand that and they can do all of this, no problem. One of the reasons they have to be able to do all this when it comes to different strategies, different methods, they're going to have to be able to see an area model, and whether it's complete or incomplete, be able to say, well, what was this? What was going on here? How do we complete it? How do we change it? How do we fix it? So if all they've got in their back pocket is this algorithm that we were taught, none of this other stuff makes sense to them. And then when it's time to analyze other students' work, which is a higher level of thinking, they can't analyze what this child did because they have no idea what it means, because they just know I memorized my facts, and 6 times 3 is 18, and I know I have to put the 8 down and I have to put the 1 up, and I know 6 times 2 is 12. I have to add 1 more and that makes 13, but they have no idea why that works, and they can't connect it to any other strategies. They just know a procedure. So anything we teach them can become procedure. However, we want the models like we showed here in their hands so they really get the connection and they're building from going from the concrete to the abstract. So that's the goal here. I'm going to show you some division too, because division doesn't look anything like the way I was taught, the way you were taught, not at all, not even close, but you might like it. We'll see. So we're going to do something basic. We'll just do 74 divided by 3. So some of you might be saying, wait a minute, that's too hard already. But here's what kids will do. So we're going to make a menu. And they love doing this, by the way. We're going to make a menu of everything we know about 3. So I know 3 groups of 1. I know that's 3. But is that anywhere close to 74? Nah, I want to get closer than that. I know 3 groups of 2. 2 groups of 3, that's 6. Still nowhere close to 74. Let's bump up our game a little bit. All right, I know 3 groups of 10. That's 30. That's a little bit closer, but I still want to get closer to 74 if I can. So when they're making their menu, they're just making facts that they know about 3. Maybe, well, if they know 3 groups of 10 is 30, maybe they know 3 groups of 20 would be double that, okay? I would say go with 4 or 5 facts and then stop there. And then what they're going to do is say, all right, which of these facts is going to get me really close to 74? Hopefully they'll say, well, 3 groups of 20 is really close. So 3 groups of 20, I'm going to put 20 up here, will give me 60. Okay, that's close to 74, not quite there yet, but close. I only have 14 left. And when I look at this, I don't really know how I'm going to get exactly spot on 14. If I go 3 groups of 10, that's too high. 3 groups of 1, that's too low. So I'm going to go with 3 groups of 6 here. Okay, so I'm 3 groups of 2 equals 6. So 3 groups of 2, I'm just going to put this 2, and you could put it anywhere. I'm going to put it here. Okay. Oh, you can't even see it. There we go. 3 groups of 2, right? That's 6. When I subtract, I still have 8 left. So I can do 3 groups of 2 again, because I know that fact. If they knew 3 groups of 3, that'd be a little better, but if they don't, that's fine. So 3 groups of 2, 6, and that leaves me with 2. Interesting. Well, I have 2 left over because 3 groups of 1 is 3, 3 groups of 2 is 6. There is no in between there. So what I'm going to do now is I'm adding this up. 2, 2, and 20 make our 24. but I have a remainder. I've got 2 left over. So 24 remainder 2. So this is one of the strategies we use to divide. Making that list of facts they know. And the reason we do that is because they don't know their facts. And even when you and I were in school, kids didn't learn their facts. They memorized them for a short time, and then they forgot them, they messed up on them. We don't know all of our facts. And even if kids did know all of their facts, there is a tendency that when we memorize things and don't use it, after a while, we forget it. You probably remember your phone number because you've had to remember it. You remember your address because you have to remember it, but you probably don't remember what 7 times 8 is. People forget that because they don't typically use it. But you might remember 7 times 7 and then be able to work from there. Or maybe you remember 7 groups of 10 and you can work from there. So you want to work with what the kids know. And it'd be great if they all knew their facts. I'm not saying don't do that. Definitely, if there are facts they don't know, it's good for them to know them for sure. But memorization has been proven not to really be successful for most people. Some people are really good at memorizing stuff and some people are really bad at it. The majority of people are not good at memorization, and it does not really help them in the long run. And they also don't know why they're doing what they're doing. So to be able to connect with what they do know is the best thing we can do. So this menu approach is a really good way to divide. I'm trying to think if there's anything else I should show you before we go. I'm thinking that should be enough because multiplication and division is so critical in 3rd grade. Please do work on facts. 100% work on facts. The ones the kids usually don't know or cannot remember are 6, 7, 8. They know their tricks for 9s. They know 10s. They know how to count by 5s. One of the great things about counting by 5s is they can do that pretty easily and connect it to other facts without too much trouble. So if you do have flashcards, use them. And I would encourage you to use the 7s, 8s, 6s. Those are usually the most tricky ones. It's harder to count by those. So I'm not saying don't do that. Definitely do it. But when you see these other things coming home, these other strategies, I hope this has helped a little bit to kind of show you why it looks that way. If you need anything, please do not hesitate to call me or Miss Sains. We are the 2 3rd grade teachers, and we are here to support you. So if this is not making sense and you want to do a Zoom call, I can show you some other things that we do in the classroom as well. There's some things behind me right now that might be helpful. We're currently talking about length times width for areas of rectangles, and it's helping them to work on their facts. They're starting to know their facts just from building these. They build them with square tiles, and we talk about that a lot. So that helps. Also over here, we're representing behind me here multiplication in different ways by showing groups of, by skip counting, and by relating that to arrays, repeated addition, everything. So it all kind of builds off of each other. The 2 things I just showed you with the multiplication and division, we're not quite there yet, but it is going to be a big component of 3rd grade. And then we are going to be moving on to fractions. So I strongly recommend doing any of the activities from this lovely packet of stuff. I also recommend doing a lot of addition and subtraction. I sent home some things, problem of the day kind of problems. A lot of it is review, addition, and subtraction with larger numbers. But there is some multiplication and division in there too, which is huge in 3rd grade. So I hope this video has been helpful. And I hope when you see these things coming home, you're going to know what's going on with it. And if not, I sent home a bunch of strategies like something I just showed you, but it's much more than that. I sent it home with all of my students, and if Miss Sains' class would like that as well, I will happily send that home. It's just, here's a word problem, here's the equation that we would use, and here's multiple strategies we would use to solve it. So I hope that was helpful. I hope you all have a lovely evening and enjoy Halloween, and I hope you enjoy the math goodies that are coming home, and we will see you at the trunk or treat tomorrow. Thanks, bye.